So I'm John Ross, a master's student here at CEFS, and before coming to the University of Washington, I was advising landscape and conservation land use decisions in south central Alaska. And for the Susitna and Matanuska valleys, which are the areas outlined in orange here, I'm using LiDAR to look both at what forest structures are there at a really high resolution level, and then also with long-term conservation decision making in mind, and long-term land use decisions, kind of why those forest structures are where they are, right? What are, in absence of these kind of stable structural identifiers, meaning there's water here, there's not here, why are these things in exactly the right location? What kind of cumulative group of things? And in the region, you can tell the why is a little bit tricky in this portion of the transitional boreal. Within relatively close proximity, you have really steep slopes, you have different slopes, you have different aspects, you have, in this instance, a contribution of glacial interference down off the screen. There's Cook Inlet, so there's a tidewater interference. And the aggregation of these things ultimately is what defines where you're seeing this arrangement of biomass. But again, what kind of accumulation of those things are the explanatory variables. So I asked you to use your imagination a little bit and see that here's how we're using LiDAR to model in three-dimensional space these forest structures both in the X, Y, and Z plane. And kind of specifically you can see high areas, right, represented by the kind of orange and red, and lower areas there. And LiDAR is great because it's allowing us to subtract topography and really isolate the heights of the forest canopy, as well as then kind of aggregate over a greater variable distance those strata, and then define individual structures therein. So based on the cover and the density of returns, we can make a really pretty accurate model at really high resolution over a huge area. So this is a figure I borrowed, so it's not from my data, but it demonstrates what this looks like in three-dimensional space. You have this really high resolution sampling of not just the top of the canopy and heights therein, but shows that LiDAR, depending on what your forest canopy looks like, penetrates a little bit deeper down in as well. So you have some representation of the understory when you're trying to define your really specific structural classifications. And what slide is next? And then moving on to how you sort of easily aggregate that over a large landscape. So this is a kilometer square, a really relatively large area. And if you allow just a smooth surface to be laid over each kind of maximum height of return, and then you aggregate maximum height of returns at maybe 2 meters, right? Then all of a sudden you can have these specific height strata represented both locally and then as they spread into whole kind of continual plains for, the whole region in that orange section was 3,600 square miles. So the resolution of sampling is incredible and well beyond what you could ever sample, kind of on your own 2 feet. And you see the histogram on the left side here demonstrates the kind of different levels of this smooth surface, how much of the forest canopy exists where. And then if you isolate individual structural characteristics, this is height an example, and just look at them across the landscape, you can even visually start to see patterns. So maybe if we look at water in this case, we see the highest level, which is this dark green, is the highest canopy or portion of the canopy story. But then on the other side, where hydrology is static around these low-lying boglands, that results in really low-lying topography and kind of that corresponding structure therein. But that's just one aspect of it. So when you're thinking about these long-term decisions and you say there are going to be variable characteristics, right? The temperature is going to be different, precipitation is going to be different. So what non-dynamic, what static explanatory variables can we piece out? So we're looking at things like soil classification, right? So this is percent hydric soils, whether there's really a lot of gravel in soils, whether there's sand in soils. Looking at these things spread over a LiDAR-derived aspect, so whether it's facing northeast, southwest, at different elevation bands, at different levels of solar radiance, effectively want to know what culmination of these things, not individual characteristics, but what culmination of these things are resulting in certain canopy structures, certain understory structures, so that wildlife biologists, conservation planners, land use planners can say, this is great habitat that in the future may be worthwhile, right? So even if certain things change, this may produce a certain assemblage of habitat characteristics that we can use, or this is an area just unto itself has really a lot of biomass, and maybe our interest is in kind of the maximum biomass, whether we care about structure or not. So some semblance of those things resulting from this characterization by LiDAR.